Hello everyone, I'm Raghav, and this is the video solution for the contest for the Leetcode Contest 384. Now, in the first problem, we have been given a m into n integer matrix, size m into n, like m rows and n columns, and we have been given a zero indexed matrix called answer. Like this is something which we have to create. We have to create a zero indexed matrix called answer. So the problem says that first of all, make answer equal to matrix and then replace each element with the value -1 with the maximum element in its respective column. And then we have to return the answer matrix. So we have been given a matrix. For now, I'm calling the matrix with name A. The given name is matrix. And what we have to do is for every element which is equal to -1 in this matrix, which is having a value of equal to -1, just replace it by the maximum value in its column. So let's say you have a -1 here in this matrix at some place. Then in that case, in the whole column, find out the maximum element and put it at this place. That's what we have to do. And in the problem, we have the constraints being very small. So even if you do it in this exact same manner, it will run properly. So if you have m rows and n columns, in that case, you will go on for every cell in the you will go for every cell. So for I equal to 0 till I is less than equal to I is less than equal to m, I is less than m, I plus plus, you will go on for every row. Then you will go on for every cell in that row. So it will be j equal to 0 to j is less than n, j plus plus. Right. In this way, you can just go on for every element in the matrix. And there you could just say, yeah, run up a for loop for int k equal to 0 till k is less than m, that is from this place to this place, and find out the maximum element. Right. You can do something like this. You could just say, yeah, you will define mx equal to -1 here, and then just say, yeah, mx equal to the max of mx and the element on that index, basically a of kj, है ना? In this way, you can just iterate over all the elements in the same column for the cell at which you found out -1. Like you will be doing this part only if there is a -1 here, and just find out the maximum value and then just say your answer of ij equal to mx. That's what you can do. I just did write up some kind of pseudocode or C++ code to give you some idea of how you can do this thing. But what if there are multiple -1s in this? What if -1 is coming three number of times and there is only one element, let's say 8? In that case, you would be running up through this column once, then again, then again. So even though the solution will pass here because we are having a time complexity of big of m square n and m and n are very small, but this is not really the most optimal thing which you could do. A better thing which you could have done is, but if you just iterate over it once and remember that for this column, the maximum element is 8. For this column, mx equal to 8. Mx is equal to 8. If you just remember this thing, then for all of those other ones, you could just say, yeah, I know the mx is 8. I will just put it there. This is something you could have done. So the more optimal way in which you could have approached the problem is go on for every column, like for first of all, considering this column, find out the maximum element, and whenever you get a -1, just say mx, like put up the value of mx there. Similarly for the next column, similarly for this column. Like in this column, when you traverse over this complete column, you will find that mx is equal to 8. After that, you will traverse over the column once again, and Anytime you see a -1, just put up 8 at that place, or put up the value of mx at that place, and for the other elements they will remain the same. है ना? You could have done it in that way. So this is a minor optimization, or actually a good optimization here. Now the time complexity will become big O of m into n. So I hope that this problem is clear. If you look at the example test case, at the place of -1, we did put up the maximum value of the column, that is 8. And at the place of this -1, we did put up the maximum value of the column, that is 9. Right. Similarly, in this example, at the place of -1, we did put up the maximum value of the column, that is 2. Now, what if there are all -1s in the complete column? You should get this kind of edge cases in your mind. By the way, that thing will not happen. They have already clarified this thing. But it is a good idea to look up for this kind of observations as well. Okay, so here is my code for the optimal approach. Now there is one difference in my code. Like, I generally prefer to keep the number of rows as n, the number of rows, and the number of rows as column. So that's a difference. Just don't get confused with it. In my code, you will see that I have instead of m comma n, instead of having m and n as the number of rows and columns, I have kept n as the number of rows and m as the number of columns. That's what, like, this is my personal preference. So first of all, I'm going on for every column. Now for every column, I go to each and every element in that column and find out the maximum element. After finding out the maximum element in that column, I will go on for each and every element in the column and just see if the element is equal to -1, then put up a mix at that place. Otherwise, just put up the original value. And in this way, you will be able to solve this problem. So I hope this problem is clear. Let's move on to the next problem. The next problem is number of subarrays that match a pattern 1. In this problem, we have been given a zero-indexed integer array nums of size n and zero-indexed integer array pattern of size m, basically two arrays n and m. And the second array pattern consists of only three elements, -1, 0, or 1. Like, every element in that pattern would be either a -1 or a 0 or 1. And we have been told that a subarray nums like from index I to j of size m plus 1 is said to match the pattern if the following conditions hold for each element pattern k. So you will say that a pattern matches the a subarray matches the pattern if for every element of the pattern, in case if the in case if the kth element of the pattern is 1, then nums of I plus k should be less than nums of I plus k plus 1. And in case if the pattern is 0, equal to 0, then this should be the case. Nums of I plus k, nums of I plus k plus 1 should be equal to nums of I plus k. If pattern was equal to -1, then nums of I plus k plus 1 should be less than nums of I plus k. And we have to return the count of subarrays in nums that matches the pattern. So I think this problem is also quite straightforward. We have been given an array of size n. We have been given a pattern array of size m. For now, instead of using the words nums and pattern, I'm using the name A and the name P for array and pattern. Now, all we have to do is we have to count the number of subarrays, count the number of subarrays of size m plus 1 which matches the pattern. Right, that's all we have to do. So I believe that this thing should be very simple for you to do. Like, you should be able to think at least this much. Since we have to find out the number of subarrays of size n plus 1, first of all, we will consider all these subarrays of size m plus 1. So for every subarray of size m plus 1, for every subarray of size m plus 1, we will check if the subarray matches the pattern or not. So check if subarray matches the pattern or not. Matches the pattern or not. Just check this thing out. Now, how will you check if the subarray matches the pattern or not? So let us take one example for more clarity here. Just um, like just to make sure that you understand how to check it. 1441, 1441, 35, 3553, 3553. This is a given pattern. Sorry, a given pattern is 1 0 minus 1. Pattern is 1 0 minus 1. The given array is this. Pattern is this. And we just have to check if it matches or not. So what will be the first subarray? Since the pattern length is like here m is equal to 3, we will have to consider the subarrays of length 4. And by the way, n is equal to 8 here. The first subarray of size 4 is 1441. So for 1441, its indices are 0, 1, 2, 3. Like for the given array, you will be able to access these elements where the indices 0, 1, 2, 3 from the given array. So first of all, we have been, and by the way, these are the indices 0, 1, 2 for the pattern. So for the index 0, it is having a 1, which means that you want here I is 0, I is 0. Right now we are talking about k is equal to 0. So I plus k plus 1, that is just 1, 0 plus 0 plus 1. For this element, we want it to be greater than I plus k, that is the previous element. And you see that it is actually greater. It is actually greater. Secondly, it has a 0. So you want these two elements to be equal. And these two are equal. Secondly, here is a minus 1. So you want this element to be smaller than the previous one. And that thing is also true. So for all of these elements of the pattern, all of the indices of the pattern, the subarray is actually matching it, matching the pattern. So you will say, "Kya, now my answer from 0, I will make it equal to 1. And now I will consider the second subarray, which starts at the index I equal to 1. It is this part, 4413. You will check out 44413, and just at the 0th index, you will realize it doesn't really pass. You want a 1. Like for a 1, what you want is the 4 should be greater than the previous element, but it is actually equal, not greater. So it will fail. Nextly, again, like you will check out for this pattern similar in the similar way. Here, this is not really greater. Like again, you will see the same thing, that it will fail for the 1. So you will check out for the next place. Here it will pass the first index, but it is not really equal. So it will fail at this place. Like I'm just doing it a little faster to keep things short. You can do the trial completely on your own after this session. Okay. So here for the last subarray, you will see the first element is actually smaller than the next one. Like 5 is greater than the previous element. That this is satisfied. This 5 is equal to the previous element. This thing is also satisfied. This 3 is less than the previous element. This thing is also satisfied. So we just found out key this subarray also satisfies. So answer will now become 2. And that's our answer here. You can do dry run for this also. Here all these subarrays follows the pattern. So you will just get 4 since there are 4 subarrays of length 3. First subarray, second subarray, third subarray, and fourth subarray, है ना? Like this fourth subarray. Here the constraints are very, very small. So even the brute force thing which we have talked right now will work. In the fourth problem, the constraints are pretty high, so we will have to come up with some optimized approach. But for this problem, the brute force will work. So what we will do is we will go on for each and every subarray of size m plus 1 in the given array, and there we will check if the subarray matches the pattern or not. That's it. That's all we will do. So here is my code. Here I am going on for every starting, like considering every element as the starting index. Then the ending index for the subarray of length m plus 1 will be start plus m. Let's say, like, um, if you have an array and you say your starting index is 0 and you want the size of the array to be 3, then the ending index would be 2, right? 0, 1, 2. Anna, these are three elements. Here what we want is we want the subarray to be of size m plus 1. So you will have to include 3 as well. That is nothing but if start is equal to 0, end is nothing but equal to start plus m here. You can just verify this thing here. And this is very simple thing. So you should actually remember this, that from 0 to from L to R, from an integer L to an integer R where R is greater, there are R minus L plus 1 number of elements if you count both L and R in this range. है ना? So just remember this part and you will never have any confusion. So in case if end is greater than equal to n, basically the subarray is end not will not really have that many elements. If you talk about the last element, like I is equal to, let's say, 7, where n is equal to 8. So if the start index is 7 and m, let's say, is equal to 2, then end will actually turn out to be 9 here, है ना? Which is greater than n. Even if it was equal to n, it will not really work there. Because right now we are adding m because we want size m plus 1. If m was 1 and we wanted m plus 2 size subarray, then end would have been equal to 8, and index 8 does not exist in the in the array, not even in the array. So we will just break. You know. After that, what we are doing is we are just iterating over the whole pattern, the pattern array, and just verifying if we have this condition being fulfilled or not. So for that, you can do it in this way. Like, this is something simple, you can understand it on your own. I'm just checking that if, like, what I wanted is if this thing is true, then it should come like this. So I said key, if I see this condition, I will store in a variable with name cur, I will store 1. If I see this condition, I will store 0. If I face this condition, I will store -1. That's what I'm doing for the integer cur. So I initialized it with 0, like just assuming that the elements would be equal. But if the elements are not equal, if the elements are having either this or the other relation, I'm just modifying the value of cur, and then I'm just comparing the value of cur with the pattern of I. In case if the cur here is not equal, then it means that the subarray doesn't follow the pattern. So I will just set OK equal to false and I will break. And in case if OK is still true, which means that I never got this condition in the for loop. If I never get this condition in the for loop and this complete for loop ends, in that case, OK would be true. So answer would be incremented in that case, else it would not be. And at the end of the day, I will just return the answer, which will store the number of subarrays which follow the pattern. So this is good. For this problem, the constraints are very small. In the fourth problem, we will see the constraints are pretty huge, where And at that place, we will use some algorithm, standard algorithm with name KMP to solve the problem. Let's see the third problem now. Now the third one is actually a bit interesting problem. The first two were very basic, just could have been solved with the brute force. This one requires you to just use some brain cells. Here we have been given a zero indexed integer, string array words having n length, and every string in this array would be zero indexed. We are allowed to perform the some kind of operation any number of times as we want, and this is the operation which we can perform. In a nutshell, I will tell that just choose any two characters from any strings in the array and swap them. They have defined it like this. Like they have just given some constraints that uh, you have to choose I and j to be in the range from 0 to n, so that words I and word j would be valid, and x and y should be in this range, so that words ix and words jy would be valid. That's why they have written those conditions. You can just ignore that for now, since we will choose only those elements. We have to return an integer denoting the maximum number of palindromes words can contain. So we have to tell how, like, since we could apply this kind of operation any number of times. So at the end of the day, what is the maximum number of palindromes which this words array can contain after performing some operations? And there is some clarification from their side that I and j may be equal during an operation. Like, just so that people might not get confused that they have to choose two different strings, you can choose the same string for while making swaps as well. Okay, so I hope that the problem is clear. Let me take an example here. Probably I will take up the first example itself. ABB, ABBB, BA, and I think the last thing was AA. Yep, it was AA. Here, what we can do is we can just first of all choose any of the strings, just choose any two strings, or maybe just choose one string. Then choose one character from the strings which you chose. Let's say I chose this string and this string, and then choose this character and this character, and now I can swap them. Obviously, here swapping will not really make any sense because both the characters are equal, but it could have made sense if I chose this character and this character and swapped them. So in that case, the strings would have become ABBA and BB, which will make this as a palindrome and this as a palindrome. And this one is already a palindrome. So I have three palindromes in this given um, array of strings. And my motive is to maximize the number of uh, palindromes I can generate. Now, remember that the problem only wants me to give the answer. It does not really want me to give the words array after making the palindromes. It only wants me to give the number of palindromes, actually, the count of palindromes. That's all I want to output, right? The maximum count of palindromes instead, not just count. Yeah. Now, I would like to point out one thing. Since you can choose any of these characters, like any of these characters, any of these characters, and swap them. So it doesn't really matter in which order you get the given strings. Even if you had got this string in the order as A, and BB, or maybe let me take as ABB, AB, AB, like the first case which should have been. No, like in any case you have been given it, even if you were being given something like this, since the characters are the exact same, you can just make some swaps in this given array of words and make this given array of words equal to this one. if all the frequencies of the characters are equal, you can always do this thing, since there are uh, no limit on the number of operations you can perform. So at the end of the day, we realized one thing, that it doesn't really matter which characters are there. The only thing which matters is how many times A has been coming, how many times B has been coming, how many times C has been coming, and so on. Right? That's all which matters, because you can always make some swaps and make it equal to any string you want, like in any order you want the given strings to be. Now, do I really care about the lengths of the given strings? Yes, I do care about. How will you verify this thing? Let's just take an example. If you have been given a string with 4 characters, maybe A, B, B, C, or if you were being given an array of strings like 2 strings, A, B, B, C. I hope you are able to see the difference yourself. In this given um, array of strings, whatever you do, like you are having only one string, and whatever you do in the string, in whatever way you permute it, you will never have a palindrome. Whereas in this case, you can swap this guy with this guy to have BB together and AC together. This one is a palindrome, so here your answer will become 1, whereas in this case the answer is 0. So even though the frequencies of the elements are equal here, the frequencies of the elements here and here are equal, B is coming twice and A and C are coming only once, the answers will be different. Here this answer 0 is for this guy. So this is what we noticed, that the order in which the elements have been given doesn't really matter, but the length of the strings matters. Does the order of the lengths of strings matter? Does it really matter whether a string with larger length is coming here and the length a string with smaller length is coming here, or if it was something other than this? If there was a string with length only 2 at this place, and a string with length 2 here, like length 2, and a string with length 4 here, will it really change anything? The answer is no. Whatever thing, after all the permutations you make, whatever thing you were storing here, you can just store it here, and whatever thing you were storing here, you can just store it here. So basically, whatever answer you could have for this string, you can have it for the other string as well. And similarly, whatever answer you can have for this string, you could have this for this string as well. Now, this is the way I do verify things. Just assume that if you have a different way of organizing it, check whatever thing which I could, like in this case, just imagine my answer was coming up to be A, B, B, and B, B. So what I can do is just say whatever thing was present here, just make it either here or here. And whatever thing was present here, just make it right being written here. I can always do this thing. So since I can always do this thing, I will see here the order of the lengths of the strings also doesn't matter. So right now, all you care about is the lengths of the given strings, but you don't really care about their order either. Now, tell me one thing. If you had something like A, B, and array B, is it good right now? First of all, what we will do is, obviously we will remove the characters from here. We will remove the characters from here, and I'm using underscore right now just to denote how many characters there should have been in the string. And I will store here count of A is I don't remember what I wrote. Let's say the count was 2 and the count of B was 1. Let's say if it was like this. Then what should I do now? Should I place this 2, like one of the 2 A's at this place? Should I ever do this? If I do this, I will get a palindrome. I will get a palindrome. It is a good thing. But I will not be able to create this as a palindrome. Whereas if I had placed a B at this place and 2 A's at this place, both of them would have been palindromes, right? Exactly, it will be the case. Now let's consider a case where you have something like AB, or maybe ABAC, and a B here. If you had the given strings like this, then in that case, first thing you will do is obvious. Just find out the count. You don't really care about the order in which they have given these strings because it doesn't really make any difference. A is coming twice, B is also coming twice, and C is coming only once. So now, what should you do? Um, Obviously, since the given example, like the example we have taken is very small, you can easily see here. I can just place A like this, B like this, and place C like this. I can do something like this. Now tell me one thing. Does it really matter if you had stored A in this way, or if you had stored A in this way? It makes no difference. There is no difference in this. All you care about is the whole string being a palindrome. So the first character should be equal to the last character, the second character should be equal to the last second character, and so on. Right. That's all you care about. So wait a second. Why is it not disappearing? Just 1 second. Zoom is not disappearing. Okay, fine. Yeah. So coming back to this place, if a like we just saw that the order in which we pay like insert the pairs doesn't matter. If I am inserting a B with a B at this end of this place, it doesn't really matter whether I place at these two places or at these two places or at any other places. Obviously, there is one exception. If the length of the string was odd, then I don't want to insert any element of the pair at the middle because there can be only one element being inserted in the middle, right? But it doesn't matter whether I pick, it doesn't matter whether I have A and like A, B, B, A. In this way, whether I place A at the center and B at the second and last second, or if I place B A, B. No, if I place it like this. So in a nutshell, what I want to say is, let's say A is coming 8 number of times and B is coming 6 number of times. Since I don't really care in which element I will, in which way I will uh, place those elements, I just know that I will be placing two elements at a time. I can just say that, hey, I have 7 pairs, 4 pairs of A's and 3 pairs of B's, 4 pairs of AA and 3 pairs of BB. So I have 7 pairs. Now, if I have to form a string of, how many is it? Yeah, of a string of length 7. In that case, what I will do is I will just choose, I will just place any pair at this place. I don't really care whether I place A or B. I will just place a pair. So this element would be equal to the last element. Similarly, for the second and the last element, these two would also be equal. Now I don't really care which elements would there be. Similarly, for third and the last. And for the last middle position, just imagine if I have A being coming 2 number of times and C being coming 1 number of time now. Let's say this is a case. In that case, what do you think? Should I place one of the A's at the center or should I place a C here? I probably would have understood that placing C is better. But let me take an example here. What if, just come back to the earlier example which we were talking about. A is coming twice, B is also coming twice, and C is coming only once. And I have been given two strings. The first string is of length 1 and the second string is of length 4. So should I place one of the A's here? Should I actually waste my pair? Right now, I have a pair of AA and I have a pair of BB. Should I really waste my pair for inserting an element at the center by inserting only one element? Should I waste the pair? The answer is no. It's quite obvious. If I have any element which is not a part of any pair, like I have a C which is not a part of any pair, in that case, placing it makes more sense than breaking a pair. But if it was something like if I had A being coming up three number of times, in that case, let's say C is coming zero number of times or whatever is the case, basically A is coming three number of times, then I have a pair of A and one A which is not a pair of with anyone. At last I will not be able to make a pair of this A with anyone. So if I have an element which is not a pair of anyone, placing it at the middle makes more sense than breaking a pair. And for the pairs I have, I don't really care in which way I place them. I just want that the elements at the corners should be equal, right? So now just connecting the dots from the things like the things which we have observed so far, let us just connect those dots. First thing which I will do is find count of every element. The second thing is, if I let's say have count of b equal to 7, I can just say I have three pairs. I have three pairs of b, or maybe I can just say I have six elements which are in pairs. Six, like I can just have a variable with name maybe element of pair, element of pair. Like this is a very weird name I've given right now. Let me have a zero here, and then I can just say here instead of zero, just increment six. And um, elements without pairs, I can have a variable with name elements without pairs, and inside it I can just place the remaining one, because since there are seven keys, there can be three pairs, and one of the bees will be left alone. So that bee can go here, and these pairs can go here. There are six bees being there. I can just do something like this. Now let's say if count of C comes out to be 6. In that case, I will say here there are three pairs or there are six elements which are in pairs. So I will just increment this 6 by 6 and it will become 12. And there is no element in this C which is not a pair, which is not coming up in a pair. So there will be no increment in elements without pairs. I can do something like this. Now in my code, since I was lazy and I didn't really want to think of a good name, what I did is I just called this thing as even, the numbers which are having an even count coming up in pairs, and called this thing as odd, the number of elements which are just left alone as odd. Yeah, these two are also not very good names, but I just named it in this way during the contest since I was lazy and not wanted to waste time in thinking names. So first thing we did is we found the count array. Second thing which we do is we can find out even and odd. We can find out even and odd. Even is telling me about the elements which can come in pairs, and odd is telling me about the elements which are not in pairs. Now, tell me one thing. Like now I'm taking one other example. Just imagine A is coming two number of times, B is coming once, C is coming once, D is coming once, and E is coming once. If I have the count of A being 2 and B, C, D, and E being just 1, 1, 1. And in the given words, like the words were being given in a way that this was the frequency. And there were two strings. One of the strings with length 2 and the other string with, sorry, one of the strings with length 4 and the other one being with 2. Now, which string should I really put up, like which in which string should I put up these characters? If you see, since we have already talked about even odd, right now I don't really care about the elements which I have. I only care about the elements which are in pairs and the elements which are not in pairs. So right now, here even would be 2 since there were only two A's which were in pairs, and odd would be 4 since there are four elements which are not in pairs. Now, in which string should I try to put up the elements first? Should I put up elements in this string of length 4 or 2? The answer is simple. If I can put up elements in a string of length 4, I can always put up elements in a string of length 2. Because um, inside the string of length 4, there will be a palindrome of string length 2 also. So if in case I can actually, with the elements I have, in case if I could actually create a palindrome here, I can always create a palindrome here. So picking up, if both of the string lengths were even, then picking up the smaller one makes more sense. Now let's talk about the case if there were odd length. If there are two strings with odd lengths, then which string should I pick up? If in case I could like just forget about this one now. And sorry, don't forget about this one now. Here I am picking up the smaller one. I should go on with the smaller one, because just imagine if I was trying to like here with the example I took earlier, you could have just placed AA together and BCDE here in any order to get one palindrome. But if you try to create a palindrome of length 4, you would have failed. You would have failed there. So picking up the smaller one made more sense. Similarly, here with the odd length, if you can create a palindrome of larger length, you can always create a palindrome of smaller length. The inverse is not true. It might be possible you have three A's and some thing like B, C, D, E, F. Here you cannot create a palindrome of length 5, but you can create a palindrome of length 1. So going on with the palindrome of length 1 makes more sense here. Now for even and odd, it was very simple to see. Here I will just go on with the smaller length strings and create palindromes there. But what if there is a string with length 3 that is odd length and a string with length 2 that is even length string? Which one should I make first? Again, the same thing comes up. If I can make a palindrome of length 3, just remove the middle element and you can, or like you will just get a palindrome of length 2. So making this guy is easier. And the contribution, like this will also have a contribution of just 1, and this will also have a contribution of just 1, since we just have to find out the count of palindromes. Not, it doesn't have anything to do with the lengths of those palindromes. So going on with the smaller string makes more sense here also. Like trying to create a palindrome of the smaller length string makes more sense. What if it was the other way around? What if the length of the odd string was smaller and the length of the even string was larger? Now which string makes more sense? If I can create a palindrome of this length, I can just remove this element and this thing would also be a palindrome of odd length, that is this one, right? Like I just did this a little faster this time. So again, you could just verify that if I can create a palindrome of the larger length, I can always create a palindrome of the smaller length. The inverse might not be true sometimes. We took an example, I guess, yeah. Or maybe I can just give an example here. But if I have A coming up 3 number of times and B, C, D, E coming up other than it, so in that case, you can never create a palindrome of length 4, but a palindrome of length 3. So again, you saw that creating a palindrome of smaller length will always make more sense. Like in both these cases and in both these cases. Now the reason I took up all the four cases when both of them are even and both of them are odd, or if one of them is even, one of them is odd, with both these possibilities where the odd length string is larger or even length string is larger, I took up all these cases because by just looking without really thinking about all the cases one by one, I was not really having any proof with me whether having a string, smaller string, will always give me the better answer or not. You know? So we just did a dry run and like we just did case work here. So now we got the thing that picking up smaller strings will always make more sense. So what I will do is I will just simply say, yeah, sort the sizes. I can just create a sizes array I can just create a sizes array in which I will just store the sizes of the strings. And after that, I can just sort the sizes array. And by the way, I will find out this even and odd from count array. Now, once I have sorted the sizes array, what do I have to do? I just have to iterate over this and check for every string size in the sizes array, whether it is possible, whether it is possible to create a string or a palindrome, actually a palindrome of length equal to the current string size. Let's call this as sz. So whether it is possible to create a palindrome of length sz or not, just find out this thing. If it is possible, increment the answer. If possible, then increment answer, else break. Because you know that if you cannot create a palindrome of the current length, you can never create a palindrome of any larger length also. है ना? So it's good. We just uh, did some casework. Now I think that the problem is almost done. We just have some if else conditions. We just have to apply some if else conditions here, and after that, return answer. Now, how will you check if we can create a palindrome of length sz or not? I divided it into two cases. It might be possible to do it without dividing it into two cases also. But for now, I just did it in two cases. I felt it to be simpler. If sz is even, I will only pick up some pairs. If there is some even length, then I will just pick up only pairs. And I just want to check if I have sz number of elements in pairs or not. So whether even is greater than equal to sz or not. I just want to check this thing. Now, in case if it is, then I will decrement even by sz because I would have used those elements in this string. I will have like I will just decrement even so that I will know kitne, how many characters I have left, which are in pairs, and I will just increment the number of palindromes I have. In the other case, if the size was odd, let's say the size is something like this, then I want, by the way, one more thing. If let's say sz is equal to 7 and I want to find out the largest uh, even number which is less than or equal to sz, I can just say sz divided by 2 multiplied by 2. By the way, since I already know that sz is odd right now, in this case, if it is coming up in this condition, it is already odd. So I can just say sz minus 1. I'm so stupid, I missed this thing. I just wrote a generic thing. Sz by 2 into 2 will always return you the maximum, the largest even number, which is less than or equal to sz. Now, if sz is even or odd, it doesn't matter. It will just give you the correct output here. But here, since we already know that sz is odd, I can just say I want sz minus 1 number of elements in pairs. So here I want even to be greater than equal to sz minus 1. Now, if it is greater, I will say if it is greater, in that case, I will say even minus equal to sz minus 1. I have decremented sz by that, and sz will now just become 1. Now the remaining string is just the middle element. Now for the middle element, if I don't have any element which is not a part of any pair, basically I don't have any element which is left alone, which was left alone. If odd is 0, and if even is also 0, in that case I don't have any element to pick up at this place. Otherwise, if either odd is 1 or greater, in case if odd is greater than or equal to 1, I can just decrement odd by 1 and place an element there. If odd is equal to 0, in that case, I can just remove one of the pairs of mine. Let's say I had a coming up 6 number of times. I can just say, yeah, please, like I will have 4 number of a's which are coming in pairs, and I will just split 2 of them differently. and place one of them there. So odd, the value of odd will increment by one in this case. Now, there is some case work. It might not be very clear by just listening, but when you try to use your own brain at this place to do the casework, you will be able to understand it very easily. Let me show you the code of mine. Here, what I've done is I just calculated the sizes and the count array as we did, say, in the first step. Then I did calculate even and odd. You can have better names. I just had some weird names here, even and odd. After that, I just sorted the sizes array, like in the third step. After that, I went up for every possible size, string size, called it as sz, said that, hey, if it is even, like in the case we talked here, if it is even, then I only care about two things: whether sz, like whether even is greater than sz or not, or the other thing can be, if sz is greater than even, the number of elements I need is greater than the number of elements I have in pairs, then in that case I will just break that. I cannot have any more strings as palindromes. Otherwise, if it doesn't go in the if condition, I will just decrement even by sz, and if you want, you can increment answer. You can just plus answer plus plus here. But since we will be doing this thing here in this if condition and in the else condition also, I just wrote it outside the if else. Okay. Here in the else condition, I said if sz minus this part, actually you can just call it as sz minus 1. Sz is even, sorry, sz is odd, so the largest even number less than sz would be sz minus 1. If this thing is greater than even, again, you will break, because even for odd length, you required this many pairs. You required fz minus 1 number of pairs. If s even was greater, it would not come to the if condition, and it will come up to this line. You will just decrement sz. I'm so stupid, yeah. I just wrote so much worthless code. Okay, so I will just decrement sz by, sorry, even by sz minus 1. Now at this place, it's up to you whether you want to call this as sz equal to 1, or if you want to call this thing as this. Obviously, it is better to call this as 1. You already know that it will become equal to 1, but I feel that it would be more readable for others in this way. Like they will be able to understand better key here. He would have modded it for some reason, but if I just call it as 1, then people might get confused that how is it defining anything here. Like just ignore this part. You can just call it as 1 here. Or after that, you will say, yeah, though sz does not even have any significance here. Even if you just ignore sz, it does not have any significance since we are not using it any place now. We already know it will be 1. The thing is, now if the remaining characters you have, that is 0 and even and odd are 0, then break. This thing will also never come. Now try to think about it. That why would it never come? I think it's pretty simple, that even plus odd is equal to the total number of characters you have. And even plus odd is nothing but the total number of characters you have. So both of them will become 0 only when the whole, like all of the strings would have been processed. So this condition will never ever come. This condition will never come. So if you want, you can just ignore this line as well. Now the thing is, in case if you don't have any element which is not a pair of any place, then decrement even by 1, 2. Basically, you are breaking a pair. Increment odd by 2, because you are just adding both two elements as like separately, and decrement odd by 1, because you have to place an element at the middle, so odd would be decremented by 1. And that's what we did here. We just said key one of the a's will go there, so eventually odd will equal to plus equal to 1, or you could have said key you will here decrement even by 2, increment odd by 2. Just made, just changed, just split up a pair and added it that to odd, and from this odd you will add one of them, so odd will be decremented once. And at the end, if you did not go across any of these if condition break conditions, you would have come up to this place, answer plus plus, that's good, and return the answer. So that's it for this problem. I hope that this one is clear. Now, if you look at the time complexity, Here we are having a loop of big O of n into m, where m is the length of the words. For now, I'm just assuming that m would always be 100. Like I'm just assuming that all the strings would be of length m. Basically, it will be equal to the number of characters you have overall in both the strings and like completely in all the strings. And this would also, this will be just complex, sorry, this will be a simple constant time complexity. And here we have a big O of n time complexity, in which we are just doing some operations in big O of 1. So overall, this loop will take big O of n time complexity. So the overall time complexity for this problem would be from these two loops, which is having um, the the total number of characters. The complexity is in order of this thing. And for the space complexity, it is also equivalent. This thing is also having that much space only. And the space, the uh, vectors which we have declared are taking only a big of n time n space complexity at max. This is taking a big of n space complexity at max. And you will see that the overall time complexity which we got was actually the sum of the total number of words, the total number of characters in all the words, which will never be greater than 1e5. So the answer is not, like, the answer will pass very easily. The solution will pass very easily. Okay, so let us see the fourth problem now. Now, this problem is actually simpler than what we generally get at the D problem. So it is a follow-up for the second problem. The only difference is that in this case, we have the constraints being higher than the last time. So what we can do here is, we can just say, uh, let me read it once again. Yeah, we will have an array nums. For now, I will call it as A only. And you will have a pattern. I will call it P for now. Nums is of size n and pattern is of size m. And you can see that there are some conditions that if pattern of k is equal to 1, in that case, this is the part. If pattern of 0 is this, then this is the condition. If pattern of k is equal to -1, then this is the condition. Right now, I'm going a little fast because we have discussed the very same problem in problem 2. So everyone coming up to this problem already knows about the problem already, and you have already solved the problem now. So I'm not explaining the problem again. Uh, the only difference is that we have to do write up a more optimal approach here. See, we have been told that if this condition holds, then this should hold. If this hold, then this should hold. And then if this holds, then this should hold. Now the thing is, if you compare any two integers, you will have only one of these three results. Either the first one would be greater than the other, or both of them would be equal, or one of them would be smaller than the other one. You know? So what we want is, like, what you can do is you can just say I will compare two integers. If it comes out to be greater, then I want one to be like pattern of k to be 1. You can say it in this way also. Like what we are saying is, if you say, what we have right now is, if pattern of k is equal to 0, equal to 0, then we have some condition. We have some if and else for pattern equal to 1 and pattern equal to -1. And then we have some conditions which we want to be true. Now the thing which you could notice is, um, other than these three, like if you compare two elements other than these three, you don't have any other possibility. So what you can say is, for if you compare two integers, you will either have, like, let's say I compare two integers and a of I comes out to be, or actually a of I plus k plus 1 comes out to be equal to a of I plus k, then in that case, you want pattern of k to be 0. If it came out to be greater, then you wanted pattern of k to be 1. If it came out to be smaller, you wanted pattern of k to be -1. You can call it in this way as well. Now, try to think about it. And in case if you feel it a little bit confusing, there is no problem. Probably it will become more clear with the example. So what I want to say is, for this array nums, or let's take this example actually. This one is like in this example, there is nothing much. It is just a sorted array. This is better example. 1 4 4 1 3 5 5 3. Right. This is the given array. So I can say, yeah, when I compare 1 with 4, 4 is greater. है ना? At this place, it will follow the pattern only if at the index, like at that whatever index we with which we compare at some place, if the pattern contains a 1. है ना? So what if you say you will have a 1 at this place? Just consider a 1 on your own. Like you were being given an array A, just create an array B from it such that, if A of A is equal to A of A I plus 1, in that case, B of I would be equal to 0. If A of I is less than A of I plus 1, like if the element on the right, A of I plus 1 wala part, is greater than without plus 1 wala part, that is element on the right is greater than the element on the left. In that case, the problem wanted us to have a 1, so we will just say bi equal to 1. And in the else case where ai is greater than ai plus 1, bai would be equal to -1. Just create an array b like that. So here you will have 1 0 -1 1 1 0 and -1. Right. Let me write it more clearly here. Right. Let me write it more cleanly actually. 1 0 -1 1 1 0 -1. From the array A, I got this kind of an array. Now what I have to do is, like the part which I was doing earlier is, I was just verifying if this thing actually follows the pattern or not. Now I have actually, from this thing, I have actually created some variable which the pattern should have got. So if the, like for checking if this string, if this subarray follows the pattern 1 0 -1, I don't really have to compare the elements again and again. Now I just have to say, yeah, if in the array B I have a 1 0 -1, and in the pattern I had a 1 0 -1, then this subarray, like this subarray, would have matched the pattern. You can try to verify this thing. This is a pretty standard manipulation. Like this kind of simple manipulations are being done very frequently in a lot of problems on code forces also, where we just manipulate the problem a little bit for our convenience so that we don't have to write up, or like we are able to see the problem in a simpler way. Now what I have to do is, I just have to find out 1 0 -1. I just have to find out how many subarrays are there in the array B which are equal to this thing. How many subarrays match to this or are equal to this subarray or are equal to this array P. I just have to find out the count of subarrays in array B which are equal to array P. By the way, one more thing. Array A initially had n elements. Array B will have n minus 1 elements. And array P is still having m elements. Now what I have to do is, I just have to find out how many subarrays are there in this array P which are equal to, sorry, how many arrays are there in, how many subarrays are there in the array B which are equal to array P, This thing can be done in something like big of n into m also. This is a very simple problem now. It can be done in big of n into m also, but this one will also give us a TLE. We have to do some better or some more optimal thing. And if you remember, like if you have studied about KMP, you should already get the intuition that this is nothing but a very simple manipulation in the problem. Like if you have studied about KMP, you would have seen that the most basic or the standard problem for KMP is string matching. Or if you have done any algorithm related to string matching, not just KMP, if you have done any problem or any algorithm for string matching, what do we do in string matching? We have been given a string. Like in string matching, we do have a string, let's say text, and we do have a string, let's say pattern. And there we would have to find out how many substrings are there which are equal to pattern, or how many times pattern is coming as a substring in the text. That's what we do. Here in this problem, we have to tell how many times the array P is coming up as a sub array, right? So you can just run up any algorithm like KMP or maybe the string hashing or anything to find out this part, just how many times it comes, and that's it. So what I would suggest you to do is learn about KMP, learn about KMP. Once you're done with it, after that, solve a string matching problem. Solve a string matching problem, which would be very standard for KMP. That is the learning part you should do. And once you're done with it, you don't even need any editorial. You will be able to do the problem. You will be able to solve this problem on your own. So yeah, in the video editorial as of now, for the fourth problem, we are not really having much of an editorial. The only part related to editorial was this part. The other part is something which is very standard. You will find tons of resources for learning KMP, and after learning KMP, you will get many problems. You just have to solve one string matching problem. You will get this kind of problems in at a lot of places. It won't be hard for you to find it out. And once you're done with it, just solve the problem. You will be able to do it on your own for sure. Now let me show you my implementation to give you some idea. By the way, one more thing. People generally have some templates for this kind of things, like string algorithms also. Similarly, like you would have seen for things like segment trees and all. So you can just have a template of your own for string matching. Um, just copy paste that template into the code. By the way, copy pasting is allowed in contests like for Leetcode as well, and for other platforms like Codeforces, CodeShift. Copy pasting from somewhere which is from a resource where the code is already available even before the start of the contest is permitted. You can do that thing. So if you want to go to GFG or someone's GitHub and copy some code, you can do this. Now the thing is, in this problem, first of all, I just took the input, sorry, not the input, but the size of the two uh, pattern and the given array. Though I don't really need them, I never used it anyway. I can just remove it. Here I have the array B which I created of size n minus 1. I just created it like this. It's a bit simple. You can understand it easily. And after that, I said key. I will just call the KMP search function of mine, which I also copied from somewhere. I will pass on the array and the pattern. It will return me the number of times the subarray B has been coming up in the array B, and I will just return that output. And in the KMP function, like you don't really have to understand it right now. You can just study about it, and later on, you won't have to understand it even then. Just write your own template. I will also do this after the session. Just do this. Make sure that every time you find out a pattern, you are actually incrementing the count. You know, just make sure this thing, like the template I copied was not really doing this thing, but I changed it a little bit. So that's it. You don't really have to understand this part. Just like study about it on your own. You don't have to worry about this part as of now. And once you are done with KMP or any other string algorithm problem, maybe like string hashing or anything, just come back, solve the problem. You will be able to do it on your own, and that's it. So thank you for watching the video. I hope it helped you out at some place. And by the way, guys, you can check out the TLE's 31 like some 31 sheet. I don't really remember the exact name, but you can get it on the TLE's website. And if the video helped you out, you can consider liking the video or subscribing to the channel. Thank you for watching. Bye bye.